In this session, we will discuss about the interval scale and ratio scale. It is because in the previous session we have finished up to interval is up to ordinal scale, including ordinal scale. Therefore, we have now remain two scales of measurements to discuss for this session. And if I started from the interval scale of measurement, the interval scale is a quantitative measurement scale where there is an order. The difference between two variables is meaningful and equal, and the presence of zero is arbitrary. If I explain on that wording, it simply says that interval scale is a quantitative measurement. Therefore, so far what we have discussed was the measurements related to, or this interval of the scale of measurements related to qualitative measurements, more or less. The ordinal scale and the nominal scale were for qualitative measurements. Now, but for if we are considering interval scale of measurements, this is associated with the quantitative measurements. Therefore, if you are having quantitative data, then we can categorize it under interval scale based on the following properties. When we are discussing about the previous two scales of measurements, we have discussed about the nominal. In there, what we have just was, there was an identification. There was an identification. It is what we have observed. But once you come to the ordinal scale, what we can see is there is an identification for each level, and there is an logical order as well, whether it is increasing or decreasing manner. We had an order for the data associated with the ordinal scale of measurement. But once you come to the interval scale of measurements, we can see that there is an identification. It is because we are having a value. Since we are having a value, it is unique for that point. Therefore, we can say that there is an identification. As an example, if you are measuring the temperature, then we can say that it is a quantitative measurement. And we can see that we can obtain a value for the measurement of which we are taking for the temperature. Then we can say that we are having an identification at that point. Thereafter, we can see that if you are considering about, if you are just comparing this 70 degrees with 20 degrees, then you know that 70 is higher than 20. Therefore, we can say that there is an order as well. Therefore, we can say that for the interval scale, the interval scale of measurements has a logical order. And the next important thing is the difference between, consider about this. The difference between two variables is meaningful and equal. It is a thing like this. Now think about if I am taking the example of measuring the temperature, then we can see that the temperature is quite, now think about it is here 20 degrees, then here it is 30 degrees, and I am considering 40 degrees and 50 degrees. If you are considering this interval and the interval from 40 degrees to 50 degrees, if you are considering this as the first region and this as the second region, both of these regions have the same meaning. It means that if you are considering the first region or the first interval, then we can say that there is a difference of 10 degrees. The temperature difference is 10 degrees. And for the second region as well, we can see that there is a temperature difference of 10 degrees. Therefore, if you are considering these equal intervals, they should have the same meaning in this interval scale. It should be, it cannot be very within this interval scale. It should be have the same meaning throughout the entire interval scale. And the next important thing is there is a Zero is arbitrary. It means that there is we can say that zero is a relative measurement for this. When we are discussing about this arbitrary zero value, zero can be considered as a true 0 point or as an arbitrary 0 point. If you are considering the data associated with the interval scale, then the next important property is we can see that zero is arbitrary. It means that there is no true 0 point. It is quite like this. Consider an example of measuring the temperature in Celsius scale. If you are considering the Celsius scale of Celsius scale to measure the temperature, if you consider about 0 Celsius or the 0 degrees of Celsius, then you cannot say that there is no temperature. This zero is an arbitrary value. It is because now think about this zero, then we can even though we are considering 0 degrees of Celsius, it has a meaning. It means that there is somewhat a temperature. It is because simply we can say that 273 kelvins. Likewise, we can interpret, we can have a conversion. Therefore, we can say that even though we are having a zero there, this does not imply that actually this does not say that the temperature at this point is zero. There is a temperature, but once you measure this temperature using Celsius scale, then you will get it as zero. But now think about the next part of this. It measures variables that exist along a common scale at equal intervals. This is what I have explained here. Then the measures used to calculate the distance between variables are highly reliable. It means that if you are using this interval scale of measurements rather than the ordinal scale or the nominal scale, here we have to deal with this quantitative measurements. Therefore, the measurements obtained under this scale, interval scale, would be highly reliable. And we have already discussed about this part as well. The intervals have the same interpretation throughout. It means that if you are considering the first region, we are having an interpretation that in the the region number 1, we are having a difference in between these two temperature values, as well as for the region 2 also, we are having the same meaning. And the next important thing for the interval scale is arithmetic operations are applied for variable on an interval scale. Therefore, if our variable is in the interval scale of measurement, then we can perform the arithmetic operations. But for the scale of measurements that we have discussed so far, ordinal scale or the nominal scale, we cannot perform such arithmetic operations for the data or the data obtained under nominal scale of measurements or the ordinal scale of measurements. Therefore, if you are obtaining the data or if you are assigning the variable under interval scale of measurement, then the next important thing is you can apply the arithmetic operation. It means that you can add any two values, you can divide them, multiply. All these arithmetic operations would be appropriate if your variable is in interval scale of measurement. In here, we can consider these some examples. First example I have taken here is temperature in Fahrenheit scale, or actually this is or Celsius scale, not with the kelvins. Here, if you are measuring the temperature in Fahrenheit scale or the Celsius scale, we can consider it as an interval scale. It is because it has an identification. It has what we can say, it has an order, and it has the same interpretation throughout the considered interval, as well as there is no true 0 point. It means zero is arbitrary. It is because if you are considering the 0 degrees of Celsius, it does not imply that there is no temperature. There is somewhat a temperature. It is measured as zero. But if you do the same thing for the Fahrenheit, If you are using the Fahrenheit scale, then you will get somewhat here, you will get 0. Therefore, if it is Fahrenheit, then you will again measure the temperature at this point. Then there will be somewhat a temperature. That's why we have obtained it as 0. But if you are measuring it using Kelvin scale, it will be a totally different case. In the Kelvin scale, if the value is given as 0, then there is no any temperature there. That is how we are defining the true 0 point in measuring the temperature. And then the next example is time of each day in 12-hour clock. If you are considering the time of each day, then it is actually relative measurement we are taking. We cannot say that if anyone says that we are starting it from 1, then the starting point is 1, then it will be arbitrary 0 value. There is no any exact 0 point. It is because we are measuring the same point twice a day as well. Then we can consider these as some examples for the interval scale, and as well as that some interpreting this age as the interval scale as well. Then we have to move for the next scale of measurements. Here we will consider the ratio scale of measurement, and this would be the last scale of measurement considered for the scale of measurements. Consider about the ratio scale of measurement. Ratio scale is a type of variable measurement scale which is quantitative in nature. It is quite simple, same as this previous one. If we are having the quantitative measurements, we can categorize some variables under the ratio scale as well. It is because when we are discussing the things in the previous session, we have considered this manner as well. If we are having a nominal scale of measurements and ordinal scale of measurements, we tend to categorize them under qualitative measurements. Qualitative measurements, sometimes I told that ordinal can be considered as the quantitative as well. But if you are considering about the interval scale of measurement and the ratio scale of measurement, then we can say that this deals with the quantitative scale of measurement. Therefore, this is how we are categorizing the scale of measurements based on the qualitative and the quantitative scale of measurement. When we are having our variable in the ratio scale of measurement, this allows us to compare the intervals or differences. In the previous one as well, we had the same thing. We can compare the differences and we can compare the intervals as well. It is because throughout the intervals, it gives the same interpretation. It means that quite simply in the previous one, if you are measuring temperature in Celsius scale, then if you are having 20 and 21, there is always a difference with 1 degree among these 2 points, and this would be same as even if it is in 30 and 31. Likewise, we have the same interpretation throughout the same intervals. In the ratio scale as well, we have the same thing. If you are considering 20 centimeters with 21 centimeters, we will have a difference with 1 centimeter, and we will have interpretation that there is a 1 unit increment in this. Then if you are measuring it 30 with 31, we will have the same interpretation in here as well. But if you are differentiate this interval scale with the ratio scale, we can see that the ratio scale possesses a true 0 point. Therefore, there is a true 0 point included in the ratio scale. Therefore, we can say that it is the origin for the ratio scale. It means that if true 0 exists, then as the meaning of 0, we can say that there is nothing at that point. And simply, we can say that if you are measuring a height of a student, if it says that there is true 0, we are categorizing measuring heights under this ratio scale of measurement. Therefore, we can see that there is a true 0 point. It means that if we are getting the height as 0, then we can say that there is nothing there. If you are measuring the temperature in Kelvin scale, then again we can say that there is no any temperature there. It is exactly zero. But if you are measuring the temperature in zero, this Celsius, the 0 degree of Celsius does not implies that there is no temperature. There is somewhat a temperature. The temperature value is zero. But if you are using Kelvin scale, then there is a true 0 point. It is the special thing in the ratio scale. It is the only difference between the interval scale with the ratio scale. Since we can since we are having a true 0 point, then it is sensible to discuss about one value being twice large as another, or it is half from the next one. Likewise, we can have a comparison. Since we are having a 0 point, it is sensible to talk about those whether one value is twice large or thrice large as the previous one. And I have discussed about this point. The intervals have the same meaning. I have said it. It is same as this previous one, interval scale. And the next important thing for this ratio scale of measurement is arithmetic operations are appropriate. Means that we can apply the arithmetic operations in the ratio scale of measurements. Therefore, when we are discussing about this ratio of scale of measurements, this ratio scale of measurements is the widely using scale of measurements in statistics. Therefore, rather than using this nominal, ordinal is also using and interval is also using. But if you wish to apply much more powerful test, then all of them are based on the basis of this ratio scale of measurement. And arithmetic operations are also appropriate for this ratio scale of measurement. And we can consider these as the examples for the ratio of measurement, ratio scale of measurement. And if suppose that if you are measuring a weight of a student, then we can see that zero weight. If you are measuring the weight, consider about this, it has an identification. It means that we are having a value to identify a point. And if you are considering the next one, there is an order. It is because we can say that 50 kilograms is greater than 40 kilograms. Therefore, we will have a logical order there. And the next important thing is true 0 point. True 0 point, and the fourth one is what we can say that there is a same interpretation throughout each interval. Therefore, if you are considering this weight, then we can compare. If you are comparing in two students, you can say that this student is twice way than the student B. Student A is twice way than the student B. And for the height also, we can say that here we can see that first two is satisfied, identification and order is there. If you are considering the height, there should be a true 0 point. It is because if you are measuring the height, if you are getting it as 0, then there should not be any height there. Therefore, we can have to say that there is a true 0 point. Then if you are measuring the heights, then you will have a true 0 point. Then it is sensible to talk about how one thing is, if you are measuring the heights, it is sensible to talk one is larger, twice or thrice than others, or just the half. Likewise, we can have the comparison among these measurements as well. Then temperature in Kelvin scale, here actually it is based on this Kelvin scale. Only for the Kelvin scale, we will have a true 0 point. If you are measuring the temperatures for the Celsius scale or the Fahrenheit scale, we do not have any true 0 points. That's why even though we are considering measuring of temperature, according to the measurement or the scale we are using, if it is Celsius or Fahrenheit, then it is coming under interval scale of measurement. But if it is measured under Kelvin scale of measurement, Kelvin scale, then it falls under the ratio scale of measurement. And the next thing is the time is spent on studying for examination. Here also we can see that identification and order is there. If one is not spending any time on the studying, then we can say that there is a true 0 point. The time is spent for studying, if it is, if that value is 0, then we have to say that there is the person has not done any studies. It is because value is 0. Therefore, since we are having a true 0 point, then we can, it is sensible to talk about whether one is studying twice or thrice more than the other one, or one is studying half as the others. Likewise, we can have the comparisons as well. And so far, we have discussed all these properties for nominal scale, ordinal scale, interval scale, and ratio scale of measurements. Therefore, if we summarize all these properties, then we can obtain a table in the following way. Therefore, if I go through this scale of measurements in the first column, then I have defined these 4 columns as identification, magnitude, it means that order and the magnitude, then equal intervals, it means the same interpretation throughout equal intervals, and the existence of the true 0 point. If you consider about the nominal scale of measurements, we will have just an identity only. There is no magnitude, there is no equal intervals, there is no true 0 point. As an example, if you are considering about the hair color of a student, then we can have the color as an identity only, but there is no magnitude for color, there is no equal interval of colors, then no any true 0 point for colors. It is because basically this is categorized under categorical or this qualitative measurements. We can have an identity if our scale of measurement is nominal. But once you come to the ordinal scale of measurement, we will have the identity, definitely we must have. And in the word itself, there should be a logical order. To have a logical order, we must have a magnitude for the measurement, and there is no any equal interval or no any true 0 point if you are considering the ordinal scale of measurement. Then we will consider about the next scale of measurement as the interval scale of measurement. If you are considering the interval scale of measurement, here we can have an identity. It means that identification is there, then magnitude is there. It is because there is a logical order as well. Since we can have a logical order, then there should be a magnitude. Then equal intervals as the explanation for the interval scale of measurement. It says that there is the same interpretation throughout the equal intervals, and there is no any true 0 point. Based on this existence of or the absence of true 0 point, we are identifying the ratio and the interval scale of measurement. Therefore, for the ratio scale of measurement, we can have an identity, we can have an magnitude, and we can have an equal interval, as well as the next important thing is we can see a true 0 point there under the ratio scale of measurement. This is one exercise given here, and based on the things that we have discussed so far, you can try for identification of scale of measurements for the following scenarios. And this is all what I need to discuss for this session, and thank you all for joining with this session.